Use logarithmic differentiation to find dy dx as a function of x. Okay, as I look at this, I have y equal x to the tangent x. Remember when we have x both as a base and as an exponent or a function of x in both places, that we are going to need to use, as they say here, logarithmic differentiation. We're going to take the log of both sides so we can use the third property of logs and get that tan x so it's not in the exponent. So we're going to start by taking the natural log of both sides, and this is x to the tangent x. And so now we will take that tangent x and we will move it out in front. So we have the natural log of y equals tangent x natural log of x. Now we don't have an x or a function of x in the exponent, so we are going to take the derivative of both sides. And we have to remember when we take the derivative of y that the chain rule applies and we need to multiply by the derivative of y. So looking at this first side, the derivative of ln y is 1 over y times dy dx. And then the second side, the tan x ln x, that's a product. So we need to do a product rule first, which is tan x times the derivative of the second. The derivative of the second is 1 over x, so we can just put that over x, and then plus the second, which was ln x, times the derivative of the first. And the derivative of tangent x is secant squared x. So now we want to find dy dx, so we're going to multiply this side by y, and we'll multiply this other side by y, but we don't want it in terms of y, we want it as a function of x. So dy dx will equal tangent x over x plus secant squared x natural log of x, and that whole thing will be multiplied by y, but y equals x to the tangent x. So we're going to replace the y with that function of x.